questions that contain the words must be and could be. Right? These are two really, really important phrases, and the way you respond to those phrases is going to make a huge difference in whether you're going to get the question correct or incorrect. So let's start with could be. So if a question says which of the following could be true, they're asking which of the following could be true at least once. That is, it only has to be true once. That is, if it's not true one time, that doesn't mean that answer is out, right? Which means that you're really looking for opportunities to prove an answer choice true at least once, right? So when you see the phrase could be in a question, the question's really asking what will be true at least once, and your goal should be inclusion and not elimination. That is, you should go through the answer choices and look for some instance in which one of the answer choices is true, right? The second you found an instance in which the answer choice is true, put a check next to that answer choice because it's in. You don't need to test it anymore because the question's asking could be true. That is, it only has to be true once. The second it's true once, you're done. Now the big question is, how do you know you're done? And the answer is, you've done your best, right? Or you know something about that particular concept. You know, it's testing odd and even, you tried an odd, draw an even. We'll see an example in a second. But with could be questions, you're looking to put checks next to answer choices, not crossing off answer choices. Now, must be questions, on the other hand, you're looking for opportunity to get rid of answer choices because a must be question, if it says which of the following must be true, it is really asking what is true in every single instance. That is, no matter what number you put in within the restrictions of the question, it will always get a true result, right? So instead of looking to put checks next to answer choices, you're actually looking to eliminate answer choices. So could be questions, checks. Must be questions, you want to get rid of answer choices. So the second you find one instance in which it doesn't work, you get rid of it. So you see how it's sort of the opposite of what you're doing with could be questions. And again, we're going to take a look at a few examples of those in a second. Remember, could be, checks, must be's, cross off. Let's get started. Okay, so quick review. We're talking about could be and must be questions. If it says must be, the question's asking what will always be true, which means that you should be looking for exceptions. That is, the second you find one doesn't work, you cross it out. If you're dealing with a could be question, you want to look for what's true at least once, right? That is, your goal should be looking for inclusions, and that is the second one works, you should keep it, right? So let's take a look at a could be question first of all, right? It says x is a positive even integer and y is a negative odd integer. Which of the following could be equal to x plus y? So each of these only needs to work once. The second it works, I put a check next to it and include it, right? So, positive even integer, write that down here just so I can remember, positive even, and y is a negative odd. Okay, so I can handle this conceptually, that is, I can sort of use what I know about evens and odds and negatives and positives, or I could just try out numbers and see what happens. So for instance, let's see if I can land on one of these numbers. Well, let's say I choose 4 for x, and y is negative 3. If I add them together, I'm going to get 1. And what do you know? That's what I was aiming for, right? So the second I got that to work, I put a check next to 2. Now, I can enrich this experience a bit by getting rid of answer choices that don't have 2 in them, right? So I know that A is not going to be the correct answer. I know that C is not going to be the correct answer because they don't have, and D, because I know that 2 is not going to be 2 isn't included in those, right? So at this point, I know that 2 works, and I just basically need to identify whether 2 or 3 is going. 1 or 3 is going to work. So if I do, then I am done, right? Good. So let's see if I can get 0. Well, I can try out another set of numbers, but I can already see that if one's even and one's odd, it's not going to work, right? There's no way I can get 0, right? And if I try to get 2, I can't think of any way I'm going to get a difference of 2 between an even and odd, right? It's going to be an odd difference, right? Odd minus an even is going to be odd. So in that case, I know that 1 is out, I know 3 is out, therefore 2 is the correct answer. 2 only. Okay, so remember, with could be questions, you really want to look for opportunities to check them off. And that'll help you understand the situation, in which point you can make a jump, as I did, to using the process of elimination. So let's try a slightly more sophisticated question. When the circumference of a certain circle is divided by pi, the result is the square of an integer. Which of the following could be the radius of the circle? Whew. All right. So circumference is. Now this is a good instance of when you should actually actively use the answer choices and see if you can make them true by targeting each one. For instance, if I said that 4.5 is the radius, right? Well, if that's the radius, and they want to know something about the circumference, right? So let's find the circumference. The formula for circumference of a circle is 2 pi r, right? So let's put that into here. So 2 times 4.5 is 9, and that's 9 pi, right? So that's the circumference if the radius is 4.5, right? That says if it's divided by pi, the result is a square of an integer. So divided by pi, the pi drops out, and that's 9, right? 9 is certainly the square of an integer, right? 3 squared is 9, right? So I know, again, that 1 works, so I don't need to keep testing it, because with could be questions, I immediately check off an answer the second it works. So again, I can cross off any answer choice that does not have 1 in it, right? Good. So let's just do the same thing with 9, right? Kind of painted myself into a corner here, so I'll do it over here. If the radius is 9, then the circumference is going to be 18 pi. If we divide by pi, we're going to get 18. Now, is 18 the square of an integer? Remember, integer is a whole number, no fractions, no decimals, right? So, no, right? Square root of 18 is not an integer, right? So we're going to get rid of that. So again, we can get rid of answer choice E. Now, let's try Roman numeral 3, right? So let's try 18. If 18 is the radius, then the circumference is going to be 36 pi, right? And if we divide by pi, we're going to get 36, right? Is 36 a square of an integer? Yes, 6 squared is 36, so 3 works. And again, there we go. So remember, when you're dealing with could-be questions, you really just want to look for one instance of truth, right? The second it works, it's in. You don't need to worry about that one anymore. So let's try a must-be question and see the difference, right? So as a reminder, with must-be, we're looking for opportunities to cross them off as opposed to opportunities to check them. That's a really, really important distinction. So let's look at number 4. It says, if x plus y is less than x, which of the following must be true, right? So 2 ways we could do this. We could do this mathematically, or we could do this with our own numbers. This one is a 4, so it probably makes sense to just do this mathematically. So we have x plus y is less than x. If we consolidate a bit, we subtract x from both sides, which is totally okay. We get them to drop out on both sides, right? And we know that y is less than 0, which is e. So that was pretty straightforward, just solving algebraically. If you didn't know how to do that algebraically, you certainly could have tried out numbers, right? So let's just say we didn't have a number, or we didn't know the algebra. Let's say we tried a number. Let's say we said x is 4. Now, in order for x plus a number to be less than x, y would have to be negative, correct? Which again concludes that. But let's just go through the methodology here. So we know that y is less than 2, right? I'm sorry, y equals negative 2 in this case. Well, and it's true, right? It's creating a true statement. So we look at this and we say x is greater than 0. So that's true at this point, right? So we don't do anything to it. We don't cross it off. We don't put a check next to it either, because with must be, that's not our goal, right? X equals 0. We just found an instance in which x was not 0, so we can cross that off. So again, the big difference is we're crossing off as opposed to using checks. X is less than 0. That's not true right now. Y is greater than 0. That's not true either, right? So even using one set of numbers, we were able to eliminate 3 of the 5 answer choices. Now, the next thing I could do is just say, okay, well, I got to try a number that satisfies one of these conditions, right? So could I use a negative number? Sure, there's nothing that says x has to be positive, right? But again, y would still have to be negative, right? So if I chose negative 3 here, and I stuck with, again, I need something that's going to be less than negative 3, so more negative. If I chose negative 2, I would still get this to be a true statement. However, a is no longer true, therefore get rid of it, and we're left with a. So that's how you could have done this if you wanted to use numbers and look to eliminate answer choices as opposed to just doing it algebraically. Let's look at number 10. It says, on a number line, the coordinates of points A and B are A and B respectively. Nice. The distance between A and B is not greater than 7, which of the following must be true. So again, if you're really solid at algebra and you feel comfortable with this, feel free to handle this algebraically. For instance, I know that the distance between 2 points on a number line is a difference, so I know I'm going to need a subtraction sign so I can get rid of that. But let's just do this one numerically, right? So let's just pick a number line, 2 points that are less than 7 apart, right? So let's try like 3 and 10, right? A and B, right? Fine. So A is, lowercase a is 3, lowercase b is 10, right? Good. So let's just try it out, right? Let's see if it's true. In this case, 3 and 10 is less than or equal to, 3 minus 10, the absolute value of that is -7, absolute value of that is 7. 7 is less than or equal to, that is true. So we're not going to do anything with it. 7 is greater than or equal to 7. Oh, that's still true, so we're going to leave that, right? 10, 3, 13 is less than or equal to 7. That's out. And remember, when you're dealing with must be, the second it doesn't work, it's out. A minus 7. So 3 minus 7 is -4. The absolute value of that is less than B. That's in, right? And A plus 7. Okay. So I picked two numbers that were exactly 7 apart, and I only got rid of one answer choice. So what do you think I should do now? Well, let's try scooting B over a bit, right? So instead of using 10, let's use 7, because it's still true, right? The distance is not greater than 7. So the distance here is 4. Let's see if we get a different answer this time. A minus B, absolute value of that is 4. 4 is less than that. However, B is now out, right? Because 4 is not greater than or equal to 7, right? A minus 7. So we have A 3 minus -4. That's still true, right? A plus 7 is equal to B. We have 3 plus 7 is 10. That's not equal to B. All right, good. So we're making some real progress now. Lastly, let's try moving this A, and that is, let's work with some negative numbers. So I'm going to slide this whole thing over. I'm going to make A -10, and I'm going to make B negative, I don't know, 6. Who cares? All right, so A and B. And again, I only have to try out A and D as far as the answer choices go. So let's look at let's look at A minus B. So we have -10 minus -6, which is a -4. Positive 4 is less than or equal to 7. That one still works. D, though, let's take a look at that one. We have -10 minus 7 is -17, absolute value of which is 17, as 17 is not less than or equal to -6. D is out. Okay, so there's an example in which I didn't feel comfortable with the math, the algebra of it, but instead I just tried out numbers, and I got the answer pretty quickly. Again, understanding what must be means, right? Must be, again, means the second one of the answer choices doesn't work, it's out. Okay, good. Let's try next one. Again, we have a must be, so again, we're looking for exceptions, right? So any real number n which of the following must be greater than n. So let's try n equals 2 to get started. That's going to be 9. That's greater than 2. That's going to be 5. It's going to be 4. What's going to be 1? Well, that's out. And the square root of 2 is 1.4. That's less than 2. Right? So just using a normal number, we got rid of 2 answer choices. All right, well, let's try something else now. Let's try a negative number. We haven't tried one of those yet. Let's try -4, right? -4 cubed is -64, plus 1 is -63. -63 is not greater than -4, so that is out, right? -4 squared is 16, plus 1 is 17, so that is certainly greater than -4, so that stays. And then 2 times -4 is -8. -8 is definitely not greater than -4. You cross that out. Again, the second it doesn't work, it's out. So that one was pretty straightforward. Again, trying out real numbers works really well on must-be questions. Could be questions as well, right? All right, cool. Number 14, if x, y, and z are different positive integers such that x is divisible by y and y is divisible by z, which of the following statements must be true? Again, must be. Single instances doesn't work, it's out. right? So x, y, and z, x is divisible by y is divisible by z, and they're all different, right? So let's start with x, and then we'll pick y and z. Let's pick a number that has at least 2 factors. Let's start with 8, y is 4, z is 2. Again, pretty predictable numbers. So we'll test the first one. X is divisible by z, 8 is divisible by 2. Now again, we're not doing anything with that. We're not putting a check next to it because it has to work in every instance, right? We're looking to cross out answer choices. X has at least 3 positive factors. Yeah, that works. 2, 1, 2, 4, 8. That's 4 factors. And x equals yz. All right, so I didn't make any progress with predictable numbers. Let's try numbers that are a little less predictable. Let's try something like 12, 3, and 1, right? 3 is a factor of 12, 1 is a factor of 3. Okay. Now the big difference between the first set of numbers I chose and the second set of numbers I chose is I'm actively paying attention to the answers, all right? So I don't want to pick numbers that have this relationship, right? Here I chose 2 numbers that multiply to give me the third number. Here I changed that, right? So you want to be sensitive to that. So I know that 3 is not going to work, right? Because I actively chose that. So let's get rid of that. All right. So what about 2? X has 3 positive factors. Yeah, 1, 3, 4, 6. 1, 2, 3, 4, 6, and 12. That's definitely more than 3. And x is divisible by z. All right, good. Now, the thing about must-be questions is you're going to get to a point where you say, you know what, I can't think of any examples that are going to contradict that. And you have to be okay with getting there. I typically recommend trying at least 3 sets of numbers, really paying attention to the differences in the answer choices. If there's any way you can identify an answer choice that can be eliminated based on sort of properties of it, then you should go ahead. Oh, I forgot to do one thing. I forgot to cross off answer choices that have 3 in them, right? So good. So it's going to be 1 or 2 or both, 1 and 2, right? So trying to think of a set of numbers that for which this would be true and this not true, or this would be true and this not true. So, you know, if this goes into this and this goes into this, then it makes sense that z would always go into x. So I'm not sure 1 is fixable. That is provable. 2, x is at least 3 different factors. Well, you know what I haven't tried yet? I haven't tried prime numbers, and I know that prime numbers have some interesting characteristics. So let's try prime number for x. So let's say x is 5, right? That'd be 1. I can't use a prime number, can I? Because it needs, these 2 numbers need to be different. So prime numbers are not going to work. So I don't think there's any way to, find an exception to 1 or 2. So let's just do that. And that's the thing with must-be questions, is you're going to get a point where you sort of have to trust that you've eliminated all considerations. The best way to think about that is just pay attention to the wording of the question, right? In this case, the question is asking about factors, right? And asking about integers. So, your choices are limited, but when they ask about factors, I know that they are also asking about divisibility. I know that prime numbers have some odd characteristics as far as the divisibility goes, and that's what I want to really focus on. Okay, so this one's pretty tough because I need to come up with numbers that are sort of manifestations of this relationship, right? And if you can't think of something, which is totally understandable, it's a number 16, pay attention to the answers, right? You try them out, right? Because the question says must be true, which means that one of the answer choices has to work. So A equals B. Well, if I choose 2 numbers that equal each other and they both have to be greater than 2, that's not really going to work, right? I know that 2 times 2 is equal to 2 plus 2, but like 3 times 3 is not the same as 3 plus 3, right? So that's clearly not going to work, because again, must be means that it has to be true. A is equal to 0. If we try A is equal to 0, we have 0 equals some number, 0 plus some number greater than 2. That's obviously not going to be true because 0 times something is 0. So you see how I'm using the answer choices to guide what numbers I pick? All right, so let's try A equals 1, right? Well, if A equals 1, we're going to have 1 times a number greater than 2, 3 for instance, is going to equal that number plus 1, right? And that's clearly not going to work either because 1 times 3 is 3, and 1 plus 3 is 4, so that's not going to work. So this is pretty cool. The last two answer choices are actually going to give you a lot of insight into what characteristic of A is important, right? So A has to be either between 0 and 1, that is a fraction, or it has to be between 1 and 2, that is some number like 1.5. So let's try numbers out here. So let's try A equals 1/2, right? So if we have, and let's try B equals 3. So in this case, we have 3 times 1/2, which is 1.5 on the left-hand side, and 3 plus 1/2, which is 3.5. Clearly they're not equal. So at this point, I can be pretty confident that E is the correct answer, but I really want to check my work just to make sure that I'm not doing something incorrectly. So let's try A equals, I don't know, 1.5, 1.5, however you want to think about it. And again, B equals 3. Just to see if we can get that relationship to work. So 3 times 1.5 is 4.5, right? And what do you know? 3 plus 1.5 is 4.5. Ta-da! Okay, so again, the answer choices can be a very, very useful place to look when you're struggling on must-be questions. So as I mentioned before, you really want to pay attention to the wording of the question, right? So the problem uses the words integer or number. You want to make sure you're trying out an integer fraction between 0 and 1, because those are going to be important. Those are going to have important characteristics, right? If the number uses the words positive, negative, or non-negative, you want to try out negative numbers, positive numbers, and 0, because 0 is technically non-negative, but it's not positive, right? If the question uses the words even or odd, make sure you try an even number, make sure you try an odd number. We saw that with that question. And if the question asks about squares or roots, try perfect squares, imperfect squares, perfect roots. You get the idea. So really pay attention to the wording of the question, and it's going to give you a lot of insights into numbers that you should be trying. All right, good luck.